Good morning. Okay, let me wait for 2 minutes. Let others also join the class.
Good afternoon, ma'am.
Good afternoon. So in the previous class, we were discussing about timers, right? Timers in mode 2 we completed. Okay, you just practice some more programs, example programs for timer 0 or 1 in mode 2. Okay. Again, the next one is next part of we completed this problem, I think. Assuming that crystal frequency of 22 megahertz, for generating the square wave of 1 kilohertz. Okay, that is nothing but 1 millisecond delay. For 1 millisecond delay, we were written the program. Okay, next type of programming is counter programming. Okay, in the counter programming, again, okay, in the counter programming, same as timer programming, timer 0, timer 1 will be there. In the same way, will having two counters, that is counter 0 and counter 1. As you already know, the T mod register, okay, in the T mod register, okay, this is the bit which is responsible for deciding the register is whether it is a counter register or timer register. If this is equals to 0, that register will be considered as a timer register, okay, T0 or T1. Okay, here also same register only, T0 and T1, two registers are there. Those will be considered as the counter register if T mod is equals to this particular bit is equals to 1. Okay, if this particular bit is equals to 1, timer 1 will act as a counter 1. If this bit is equals to 1, timer 0 will act as a counter 0. Okay, that is what we are going to differentiate from the counter to timer by using a T mod register. Okay, in the T mod register, this particular bit C bar T bar is equals to 1 means we are going to use the given counter as a counter 1. If this bit is equals to 1, the given counter will becomes counter 0. Okay, we'll see the different T mod values what we have to load for using the counter 0 and counter 1 in the different modes. As I already told, 3 different modes are there. Sorry, 4 different modes are there. In that one only we are going to use 3, mode 0, mode 1 and mode 2. Okay, mode 0, mode 1 and mode 2. If these two are equals to 0, 0 are for counter 0 and for counter 1 means these two will be equals to 0, 0. Okay, if you are using a counter 1 means counter 1 in the mode 1 means this will be equals to 1, 0. Okay, sorry, 0, 1. If it is a counter 0 mode 1 means this will be equals to 0, 1. Okay, and counter 0 in the mode 2 means this will be equals to 1, 0. And counter 1 in mode 2 means this will be equals to 1, 0. So we'll see different values for different cases. Okay. First, we'll take a counter 0 in mode 0. What is the T mod value we need to load if it is a counter 0 in mode 0? Okay, counter 0 in mode 0. This is for counter 1. Okay, this is for counter 0. Means the LSB 4 bits are responsible for counter 0. The MSB 4 bits are responsible for the counter 1. Okay, whenever the counter 0 is there, this part, complete MSB part, that is 4 bits, will become 0. Okay, it's similar to timers. Okay, similar to timers, all the registers what we are going to use for counters also same. Okay, same registers only. Okay, but the value here, only this particular bit will be equals to 1. The circuit, the internal circuit, everything will be same, because same part we are going to use except this bit. Okay, if this bit is made equals to 1, means that will act as the circuit will act as a counter. Okay, now we'll see the different cases. Here, for counter 0 in mode 0, okay, for counter 0 in mode 0, okay, this will be 0, and this is 0, this is 0, this is 0, okay, because we are not going to control that counter externally, we are going to make gate also 0. Okay, if you want to control that counter externally, means you have to make gate value is equals to 1. Okay, and then because it is a counter, you have to make this value is equals to 1, and it is in mode 0, means this value will be equals to 0 0. Okay, this is what the value you need to load to the mode. What is the value? This is in decimal or in hexadecimal. What is the equivalent value in hexadecimal? See, these 4 bits will be written as a 0, and next 4 bit 0 1 0 0 is nothing but 4.
0 for H.
Yeah, 0 4 H. That is what I am written here. Counter 0 in mode 0. Done. The next one, counter 0 in mode 1. If we take counter 0 in mode 1, okay, the first 4 values will be 0 0 only. Only the mode values will change. That is nothing but here, instead of 0 0, we are going to change it to 0 1. Okay, 0 1. So this value will change to 0 1. All other values will be same. Okay, this will be 1 only, and this will be 0, and these values will be 0 only, because we need to load for counter 0, not for counter 1. So what is the equivalent value here? The first one will be 0, first 4 bit, and the next one, this is 5. Okay, that is what I am writing here, 0 5. Then 0 6 means just we are going to make, see, the mode value will change for mode 2. For mode 2 means 1 0 is the equivalent value. 1 0 means we're going to write 1 0 here. Okay, that is nothing but this will be 0, and this will be 0 1 1 0. That is nothing but 6. That is what we are writing here, 0 6. Then, so similarly, this will be 4 0. 0 4 will change to 4 0. How it will change to 4 0? This part will be made 0. This complete part will be made 0. And we are going to concentrate only on this part when we are using the counter 1. So that's why this will be interchanged. Okay, this will becomes 4, and this will becomes 5. Okay, in the mode 1. Counter 1 in mode 1 means this will be equals to 1 0 1. That is nothing but 5. Okay, counter 1 in mode 2 means this will becomes 1 1 0. Okay, and other part will be 0 0 0 0. So this will be equals to 6 0. That is what I am writing in the table. Okay, see, in the same way you can make a table for timers also. Timer 0 in mode 0, timer 0 in mode 1, timer 0 in mode 2. Timer 1 in mode 0, timer 1 in mode 1, and timer 1 in mode 2. Okay, same values you're going to get. But the thing is, means for mode M1 and M0, the values will be same. But the thing is, C bar T will be equals to 0 always. Okay, 0, C bar T will be equals to 0 means you're going to get 01H, 02H, and 03H. That's all. Okay. So I think you understood how exactly these values will be loaded. Okay, for counter 0 in mode 0, counter 1 and counter 1 in mode 0, mode 1 and mode 2. Okay, next one, programming of the counters. Programming of the counters will be done similar to the timers. Okay, this will be done similar to the timers. How it will be done is, okay, these are the steps for counter in different modes. Okay, it is similar to the timers. In the mode 1, if you are doing, same circuit will be there. Okay, same circuit. If it is a T0, P3.4 will be used. If it is a T1, P3.5 will be used. That is for TR0 and TR1. TR0 pin and TR1 pin. TR0 means P3.4, TR1 means P3.5. Counter 0 means pin 3.4 will be made 1. If it is a counter 1, pin 3.5 will be made 1. Okay. Counter 0 and counter 1 is nothing but TR0 pin and TR1 pin. That's all. Okay. And then THX and TLX. Okay. Both will be there because in the mode 1, it is a 16-bit counter. Okay. Mode 1 means it is a 16-bit counter. Mode 0 means 13-bit counter. And then mode 2 means it is a 8-bit counter. Okay, it is similar to timers. Timers also same thing. Timer 0 in mode 0 means it is a 13-bit. Timer 1 in mode 1 means it is a 16-bit. And then timer in a mode 2 means it is a 8-bit with the auto reload of TH and TL value. Okay, whatever the TH value will be there, that will be reloaded to, means automatically loaded to TL value. Okay, here TH value and TL value will be different whenever we are using the 16-bit or 13-bit. In the 16-bit counter, the counter will count from the maximum values, that is 0, 0, 0, 0 to F, 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 F. Here no calculations will be there. Whatever the value we need to count, that value we are going to give it to the TH and TL value. That's all. Okay, whenever we are programming for the timers, you need to calculate the delay value and frequency value. Okay, frequency also you should calculate, and time required for one machine cycle you have to calculate, and then delay value you have to calculate. Means square wave T on and T off with the 50% delay we are going to calculate by default. But here there is no calculations, just we are going to load whatever the value we need to count. Okay, for example, we need to count from 00 to 55. We are going to use the counter, whichever the counter you want, you can use. Okay, in the mode 2. Okay, because 55 means it is just a 8-bit data. Okay, for example, if you want to count 00 to FF means that is also you can use in the mode 2 only. Okay, if it is greater than 8-bit, if it is greater than 8-bit, you go for mode 1. Okay, if it is less than 16-bit means, again, if it is less than 16-bit and up to 13-bit means you can go for mode 0. Okay, counters programmed in mode 0. Okay, for 16-bit, whenever it is 16-bit is there, you can program the counters in the mode 1. Okay, mode 1 will take maximum values up to FF. So we are going to program the counters for 16-bit. Okay, in the mode 1. X is equals to 0 for counter 0, x is equals to 1 for counter 1 means wherever the x is there, if you replace with a 0, that is a circuit for counter 0. If you replace with a 1, you're going to get for counter 1. This will be TH1, TL1, TF1 and TR1. Okay, TR1. So we'll see the steps for programming the counter. Similar steps, same as the timers. So here, the first step, load the TMOD register value with indicating which counter and which mode is selected. That is nothing but which counter means whether it is a counter 0 or counter 1. Okay, that is what I told here. Okay, the TMOD value will decide which counter we are using and in which mode we are using. These are the values for different counters in the different modes. Okay, that is done in the first step. Means first line, first instruction will always be load the move TMOD comma, what is the value we need to load. okay, depending on the given problem. Next one, load the register TL and TH value with the initial count value 0, 0. Because if it is a up counting, we should always load initial count as a 0, 0 H. Okay, and then start the timer by setting TR bit is equals to 1. That is pin number 3.4, pin number 3.5 is equals to 1. We are going to do, or otherwise just set bit TR0 for counter 0, set bit TR1 for counter 1. Otherwise, you can also do set bit pin 3.4, set bit P 3.5. Like that also you can use. Instead of that one, better to use directly the TR0 and TR1. Okay, and then keep monitoring the overflow flag bit, that is TF. Okay, we have to keep monitoring the TF bit from the TCON register. Okay, TR0 is also from the TCON register. Okay, TR0 and TF0 both are from the TCON register, that is timer control register. Okay, we should always monitor the TR and TF value whenever you are programming for timer and counter. Okay, whenever you are using counter, okay, set bit TR0, and then you should keep on monitoring the TF value, that is by using the instruction JNB jump no bit. If bit jump no bit means we are going to check whether the TF value is equal to 1 or not. If once the TF value becomes 1, we are going to jump to the next instruction. Okay, till TF value will becomes 1, it will be keep on counting. Okay, and then after the JNB TF1, TF is equals to 1, we're going to stop the counter by making TR bit is equals to 1, sorry, 0. That is previously we're going to make set bit TR0. Here what you have to do, you have to use the instruction clear CLR TR0. Okay, and then clear TF, that is nothing but CLR TF0. And then go back to step 2 by loading the TH and TL value again to 0, 0 H. Okay, we are going to load the TH and TL value with a 0, 0 H. Again, we are start counting the values from 0, 0, 0 to up to FFFF. Okay, this is what the programming of counter. Okay, whether it may be counter 0 or counter 1. Okay, depending on the TMOD value, we are going to select in the mode 1. Okay, in the mode 1 means it is a 16-bit counter. It will count from 0, 0, 0, 0 H to FFFFH. Okay, here in mode 2 means it is a auto reload counter. Okay, whatever the TH value will be loaded, that value will be loaded to TL also. But it is a 8-bit counter. 8-bit counter means it will count only from 0, 0 to FF. Okay, 0, 0 to FF. And we already know what is a TMOD value for mode 2. Okay, if it is a counter 0 in mode 2 means it is a 06. And then counter 1 in mode 2 means it is a 60. Okay, move TMOD comma 06H, ash 06H you have to do. And then if it is a counter 1 in mode 2 means TMOD value will be loaded with the 60H. Okay, immediate value, that is ash 60H you have to load. Same steps will be same. Okay, load the TH value. Only we have to load the value to the TH. Whatever the TH value will be there, that will be loaded to the TL. But we concentrate only on the TH because it is a 8-bit counter. We'll use this one for counting maximum 8-bit value. Maximum 8-bit value means all 8 bits are equals to 1. That is nothing but FF. Okay, and then start the counter by setting the TRX value, that is pin 3.4 and pin 3.5. Pin 3.4 is nothing but TR0. Pin 3.5 is nothing but TR1. You can also use set bit pin 3.4, set bit pin 3.5, or else set bit TR0, set bit TR1. Both you can use. Okay, and then keep monitoring the TF flag. That is nothing but it is a pin on the TCON register. Again, it is a pin 3.6 and 3.7. Okay, pin 3.6 is for TF0, 3.7 for TF1. You can use the pin 3.6 and 3.7, or else just directly use TF0 and TF1. Okay, by using the instruction JNB TFX, where X stands for 0 for counter 0, 1 for counter 1. And then once the TF flag is raised, that is nothing but once the TF value will becomes 1, you have to clear the TF flag and you have to clear the TR0 value or TR1 value. Okay, you have to clear. Again, auto reload the TH value with 1. Okay, that is what we are going to do in the counters. I'll give one example in the keel. Example program in the keel for counting the values. I'll give some examples. Let me show that one. So this is from your lab syllabus counter. Is this MS Office Word is visible? Word file is visible?
Yes,
Counter?
ma'am.
Okay, now this is hexadecimal up counter. Okay, program for hexadecimal up counter. What we are writing is, see, we are generating on the port 1, okay, P1 register. Okay, we are counting on the P1 register. Thus, we are incrementing A by 1. Okay, always it will increment the A by 1. A called delay. A called delay is nothing but delay program we have written here. That is for counter. Okay, delay program move R0, 60H. Okay, R0 value is loaded with the 60. Why it is 60 means, okay, we are counting 60H is nothing but this is for T-mod register. Okay, R0 is like we are using as a T-mod register. That is nothing but counter 0 in the mode 2. Okay, and R1 is loaded with a 0 FFH. That is nothing but FF is the maximum value we are counting. And then till it will become 0, it will be keep on counting. I'll show how exactly it will count. In this way also you can write, or else whatever the program we have written means according to the procedure also you can write. The timer program also you can execute in the keel. You can try those programs. I will tell you how to execute those programs. Is my keel window is visible for you?
No, ma'am. Still in the word only, ma'am.
Not visible?
Yes, ma'am. Now it is visible, ma'am.
Okay. I'll just copy paste that program. Okay. Initialize 0, 0 up, move P1. Okay. On the P1 we are counting, that is P1. And delay program we have written for the counter 0 in mode 2. That is nothing but we are counting from 0, 0 to FF. Okay. We'll add this program first. File was. Okay. I'll write counter X up. Okay. Hexadecimal up counter. Let me add that one. Add existing files. I'll go and then the X. Okay. And then you have to build this one, build this file, build a target. Okay. Before building, you should check for target also, options of target. It should be 11.0592. Okay. And then in the output, you should create the hexa file. Okay. Hexadecimal file you have to create. That's all. That is the settings for target. And then you have to check for errors. If error 0 only, you have to go for debugging. Go to debug, start the debugging session. Okay. The important thing is here it is not like other programs. Okay. You no need to check for not only check for these values, you should also check for P1. Okay. Pin number 1. Okay. P1, you should also check for P1. Where it will be means you have to go for peripherals. Okay. In that one, in-out ports will be there. See, P0, P1, P2, P3 will be there. In that one, you have to take port 1. Okay. You have to take port 1. See, now it is all the values are set. Okay. You can also reset those values. No problem. Otherwise, let it be as it is. Let us run this program. It should start from, it is a hexadecimal up counter. That's nothing but it should start from 0 and then it should end at FF. We will run this one. See, can you observe the values are changing here? From 0 it is started, 14, 15, 16, 17, up to FF it will count. You can check that one. Okay, in the same way, if you execute the down counter, hexadecimal down counter, it will start from FF and it will end at 0, 0. Okay, after ending at FF, it will restart from 0, 0 again. So any doubts with this program?
No, ma'am.
Similar to timer. Okay, whenever you are executing the timer programs, you just keep observing this one. See, you have to check these timer 0, timer 1, timer 2, you have to take. Okay, in the same way, I'll teach a serial communication also. In that case, you have to take this one, serial communication. You have to observe the values here. Okay, for timer values, you have to observe here. This one. See, tcon value will be there, th value will be there. Okay, all the values you have to observe here. This is in mode 0 now. Okay, that's why it is a 13-bit counter. Okay, you can select here. See, mode 0 means it is a 13-bit counter. Mode 1 means 16-bit counter. Mode 2, 8-bit counter with the auto reload. Okay, we are not going to use this one. It is a 2 8-bit counter actually, mode 3. Okay, that is not there in your syllabus. That's why I didn't thought. Okay, 2 8-bit counter means separately we are going to use TL and separately we are going to use TH. Okay, for counting 0 0 to FFH, 0 0 to FFH in the TL, 0 0 to FFH in the TH. Okay, you have to observe the values here. You can execute the timer programs. It is not there in the lab. Actually, in the lab, you have C programming of the timers. That's why I'll teach the C programming of the timers. Okay, only assembly language programming is there for counters. That's why I'm teaching for counters. Okay, you can observe here, once it is reached the FF, it is again start counting from the 0 0. Okay, this is a 0th bit and this is a 7th bit. Let me pass this one. You observe the values, how exactly it is counted.
Yes, ma'am.
If I start this one, instead of this, we can execute step by step also. How to execute step by step? See, function file F10 you have to use. Okay, the stack pointer will be initialized with the 0 7 and P1 value to open. Let us in out ports you have to go and then P1 you have to open. See, now it is 0 0 it is showing. See, increment A, P1 value, whatever the A value will be there. See, A1 value is, sorry, A value is incremented by 1. That value is loaded to the P1. See, P1 is loaded with the whatever the value is there in the A. Now increment A we are going to do, that is nothing but it is incremented by 1. So 2 it became. So this 2 will be loaded to the P1. Like that we are going to do. We'll be keep on executing this. That's all. Just by incrementing A value, we are going to count in this. So if I give run, it will start from there only, 14, 15, 16. Okay. Whenever you want to stop, you can stop this program. Okay. If you execute just by running, that is by pressing the F5 means you can't observe the values. If you want to observe the each and every value means you should execute by pressing the F10. Okay. F10 or F11, step-by-step execution. You can use that one. So in the same way, Other programs are there. Uh, Counting down. Okay, counting down hexadecimal is also there. Let me show that one. The hexadecimal down counter. Okay. For this one, what you have to do? First, we have to load accumulator with the FF, that is maximum value, and then go on decrementing that value. Okay, move P1 comma A means P1 will be loaded with the FF, and then decrement FF by 1. Okay, and then FF by 1 means it will becomes FE, and then FE by 1. Okay, it will be decremented by 1 means FD. Okay, it will go on do like that. Let me execute and show this program also. Just decrementing by 1 hexadecimal down counter. Okay, it will start counting from the FF down counting. So that what we have to do, you have to load accumulator with the FF, and then P1 value, P1 is loaded with the accumulator value, because we have to observe how exactly it will be decrementing. So we can't keep on checking the register value. That's why what we are going to do, we're going to load it onto the port values, so that we can observe input and outputs on the ports directly. So it will be loaded to the port register, that is P1 register we are loading. You can use P0 also, P0, P1, P2, but not the P3. Okay, you can use P0, P1, P2. Okay, not the P3. P3 is having the special function registers on the each and every pin. That's why you should not use the P3, port 3 register. Okay, you should use only P0, P1, P2. Okay, I'm using P1, and then decrement A means A value will be decremented by 1. Again, A call delay means we are going to use that one in the counter 0 in mode 2, and then FF, because we need to decrement this one by FF times, means total 255 times, because it is a 8-bit value. FF means it is equivalent decimal value is 255. 255 times it will executing. Why we are doing decrement R2, R1, R0 means it should become 0. Okay, when it will become 0, it will start counting the value. Okay, DJ and set means decrement jump, not 0. Okay, till it will become 0, it will keep on executing the program. Okay, let me execute and show this program also. Is the key is visible?
Yes, ma'am.
So let me stop this program. Take the new file. I'll give this as a counter exa down dot asm. You have to do. Okay, save this one and remove this file. Okay, add that existing file, that is down counter exa down, right? This one you have to add. Okay, you can observe here that file is added here. Now we'll build this one. Okay, you can observe here 0 errors, so that you can execute it. Start debugging. Once you do the start debugging, then only you have to observe the P1 value. Okay, P1 value you have to open. Okay. Now we'll start debugging this one, running. You can see it is decrementing. For each step, it is decremented by 1. Okay, it will start counting from the FF, and it will count up to 0, 0. Okay, we are giving this will run FF times, means counting of 0, 0 to FF, sorry, FF to 0, 0, it will count 255 times. Okay, it will count 255 times. That is what we are doing. Okay, it will be keep on counting 250. That is what the counter down program. Can you write the program? Okay, just take the screenshot of this one, this program. Let me arrange this properly. Do one thing, take the screenshot of this one. Okay, can you write the program for decimal up counting and decimal down counting? Let it count from 00 to 99. Okay, and then down counting also 99 to 00. Can you write the program for that one? Here we are doing hexadecimal up counting and hexadecimal down counting. In the same way, can you try to write the program for decimal up counting and decimal down counting?
So instead of FF, we should write AA, ma'am.
No, 99 I'm telling.
No.
Decimal 99.
Okay.
How to give? See, it started counting again. Okay, this will be done 255 times because we are giving R2 is equals to 255. If you change this value to 2 times, it will stop by counting 2 times. Okay, we'll do that one also. Okay, just close this one. Start debugging. We'll close this also. R2 comma, what you have to give? I'll give 2. Otherwise, I'll give 1 only. Okay, only one time let it execute. So for that one, what you have to do? First, you have to save. Save and then execute. Can you try running the timer programs? Okay, you have to type and run the timer programs. Only the thing is, you have to observe the result, go to peripherals, okay, in the timer. Okay, if you're writing the program for timer 0, you have to click for timer 0. Timer 1 means timer 1. Okay, you have studied only for timer 0 and timer 1, not for the timer 2, right? Okay, timer 0 you have to take, and then you should observe here. Okay, if it is a mode 1, you just take this one and then observe the values. Okay, can you do that? Write the timer 0 and timer 1 programs. Okay, I'm already given so many programs in the class. Just observe that one by executing each and every program so that you will understand very well. Okay, try some more programs for timers. Okay, take the previous question papers and write the programs for all the previous question paper problems. Any of you are having previous year question papers from microcontroller?
Ma'am.
Previous year question papers for microcontroller. Any of you are having? No one?
But I have model question papers, ma'am.
Okay, I will find and send the previous year question paper for microcontroller. We'll run this one. And you have to observe on the fourth one. Okay. It's executing from FF. Once it becomes 0, it should stop executing the program because we have given the count is equals to 1. Any doubts with this one? Execution or in programming? Okay, the counter 0 and counter 1 programming.